Hello students, welcome to class 9th mathematics. In polynomials, we are going to learn today about zero polynomial. Zero polynomial. A polynomial in variable x of degree n is of the form p of x is equals to a0 x raised to 0 plus a1 x raised to 1 plus a2 into x raised to 2 plus go up to an x raised to n, where a0, a1, a2, an are constants and an is not equal to 0. If a0, a1, a2, an is equals to 0, then p of x is equals to 0. Such a polynomial is called zero polynomial. That is, a polynomial in which all the coefficients are 0 is called zero polynomial, and the degree of zero polynomial is not defined. Zero of a polynomial. A real value a is said to be a zero of a polynomial p of x if p of a is equals to 0. This is also called as the root or zero of the polynomial equation p of x is equals to 0. It is nothing but the value of x which makes the given polynomial equation p of x is equals to 0. Let's consider a polynomial equation p of x is equals to x square minus 4. Here, when x is equals to 2, the polynomial equation p of 2 will be equal to 2 square minus 4, which is equals to 4 minus 4 is equals to 0. Also, when x is equals to minus 2, p of minus 2 is equals to minus 2 the whole square minus 4, which is equals to 4 minus 4, which is equal to 0. Therefore, 0 of the polynomial p of x is 2 or minus 2. That is, a 0 of a polynomial need not be 0. Here, x square minus 4 is a polynomial of degree 2, and we can observe that x is having two values, that is 2 and minus 2, which makes this polynomial x square minus 4 equal to 0. So, a polynomial of degree 2 is having two roots or two zeros. Let's consider another polynomial equation p of y is equals to 3y. Here, when y becomes 0, p of 0, the polynomial equation py is equals to 3y becomes 3 into 0, which is equals to 0. Therefore, 0 of the polynomial 3y is 0. Hence, 0 may be 0 of a polynomial. Let's consider a zero polynomial equation p of t equals to 0. Then, p of t can be written as 0 into t raised to 0, since t raised to 0 is equals to 1. Then, when t becomes 1, p of 1 is equals to 0 into 1 raised to 0, which is equal to 0. P of 2, that is, when t becomes 2, p of 2 is equals to 0 into 2 raised to 0, which is equals to 0. If t becomes root 4, then p of root 4 is equals to 0 into root 4, the whole raised to 0, which is equals to 0. Here we can understand, if p takes any value, even then, when substituted in the polynomial equation, which is a constant zero polynomial, it becomes 0. Therefore, 1, 2, root 4, etc. are the zeros of the zero polynomial p of t. That is, every real value is a zero of a zero polynomial. Let's consider another polynomial equation p of r is equals to r squared minus 1. Here again, when p is r is equals to 1, p of 1 is equals to 1 square minus 1, which is 1 minus 1, which is again equal to p of minus 1 is equals to minus 1 the whole square minus 1, which is 1 minus 1, which is equals to 0. Therefore, 1 and minus 1 are the zeros of the polynomial p of r. So, a polynomial can have more than one zero. Here, r squared minus 1 is a polynomial in one variable of degree 2. That is, it is a quadratic polynomial and it's having two zeros. Let's consider the polynomial equation p of t equals to 4. 4 is a non-zero constant polynomial. Then, p of t can be written as 4 into t raised to 0 since t raised to 0 is equals to 1. Then, when t becomes 0, p of 0 will be equal to 4 into 0 raised to 0, which is 4 into 1, which is then equal to 4. If t becomes 1, then the polynomial equation p of 1 becomes 4 into 1 raised to 0, which is 4 into 1 is equals to 4. Also, when t takes the value of 2, p of 2 becomes 4 into 2 raised to 0, which is equals to 4 into 1, which is equals to 4. Therefore, 0, 1, 2, etc. are not the zeros of the constant polynomial p of t. Hence, we can say that a non-zero constant polynomial has no zero. Let's consider polynomial equation p of x is equals to x plus 2. Here, a polynomial x plus 2 is a polynomial in one variable and of degree 1. That is, a linear polynomial. Here, when x becomes minus 2, p of minus 2 is equals to minus 2 plus 2, which is equals to 0. Therefore, 0 of the polynomial p of x is 2. Only when x becomes minus 2, the polynomial x plus 2 becomes 0. That is, every linear polynomial has one and only one zero. Note, a polynomial in one variable of degree n can have at most n zeros or roots. That is, a linear polynomial has only one zero. A quadratic polynomial can have at most two zeros, and a cubic polynomial can have at most three zeros. To find zero of a linear polynomial, consider linear polynomial p of x. That is, p of x is equals to ax plus b. Let p of x be equal to 0. Then ax plus b will be equal to 0. Then, shifting b to the other side, that is transposing, ax will be equal to minus b. Therefore, x becomes minus b by a. Substituting, x is equals to minus b by a in p of x. We get p of minus b by a is equals to a into minus b by a plus b. Here a and a gets cancelled. We'll get p of minus b by a as minus b plus b, which is equals to 0. That is, when x becomes minus b by a, then p of x becomes 0. Therefore, 0 of a linear polynomial of the form p of x is equals to ax plus b is minus b by a. Now let's solve the problems based on 0 polynomial. Let's find the value of the given polynomials. For example, p of x is equals to 5x square minus 3x plus 7 at x is equals to 1. Solution. Let p of x is equals to 5x square minus 3x plus 7. This implies when x is equals to 1, p of 1 is equals to 5 into 1 raised to 2 minus 3 into 1 plus 7, which makes it 5 into 1 minus 3 plus 7. That is, p of x is equals to 5 minus 3 plus 7, which is equals to 9. So, value of p of x when x is equals to 1 is equal to 9. Let's consider another example. P of y is equals to 3y cube minus 4 plus 7 at y is equals to 2. Solution. P of y is equals to 3y cube minus 4 plus 7. When y is equals to 2, p of 2 will be equal to 3 into 2 whole cube minus 4 into 2 plus 7. That is, 2 cube is equals to 8. So, it becomes 3 into 8 minus 8 plus 7. Therefore, p of minus 2 will be equal to 24 minus 8 plus 7, which is 24 minus 1, which is equal to 23. Therefore, value of p of y when y is equals to 2 is 23. Let's consider another problem. P of t is equals to 4t raised to 4 plus 5t cube plus t square plus 6 at t is equals to a. Solution. P of t is equals to 4 into t raised to 4 plus 5t cube plus t square plus 6. Now, when t is equals to a, that is substituting t as a, p of a is equals to 4a raised to 4 plus 5a cube plus a square plus 6. This is the value of p of t when t is equals to a. Let's check whether x is equals to 2 by root 3, minus 2 by root 3 are the zeros of the polynomial 3x square minus 2. Solution. Let p of x equal to 3x square minus 2. Then, when p of 2 by root 3 will be equal to 3 into 2 by root 3 the whole square minus 2. That is, substituting the value of x as 2 by root 3. It will be equal to 3 into 2 square by root 3 the whole square minus 2. Now, root the whole square will become 3 raised to half into 2. So that becomes 3. So P of 2 by root 3 will be 3 into 4 by 3 minus 2. 3 and 3 gets cancelled. So this becomes 4 minus 2, which is equals to 2. So we can understand that 2 by root 3 is not a 0 of the given polynomial. Now let's check when x is equals to minus 2 by root 3, what happens? Now when p is equals to minus 2 by root 3 is equals to 3 into minus 2 by root 3 the whole square minus 2, which is equal to 3 into minus 2 the whole square by root 3 the whole square minus 2. Here minus 2 the whole square will be equal to 4, and when we consider root 3 the whole square, root 3 can be written as 3 raised to 1 by 2 into 2 makes it 3 raised to 1, that is 3. Therefore, P of minus 2 by 3 becomes 3 into 4 by 3 minus 2. 3 and 3 gets cancelled, becomes 4 minus 2, which is again equal to 2. So we can say that even when x is equals to minus 2 by root 3, the given polynomial is not equal to 0. Therefore, 2 by root 3 as well as minus 2 by the root 3 are not the zeros of the given polynomial. That is, therefore, 2 by root 3 and minus 2 by root 3 are not the zeros of the polynomial 3x square minus 2. Check whether minus 2 and 2 are zeros of the polynomial x plus 2. Let p of x be equal to x plus 2. Then, when x is equals to minus 2, p of minus 2 is equals to minus 2 plus 2, which is equals to 0. That is, substituting minus 2 in place of x. Then, when x is equals to 2, p of 2 will be equal to 2 plus 2, which is equals to 4. Here, when x becomes minus 2, the polynomial equation becomes 0. Therefore, minus 2 is the 0 of the polynomial x plus 2, but not 2. Now we know to check whether the given values are zeros of the given polynomial. Now, let's find the 0 of the given polynomial. So first, let's take the polynomial 2x plus 1. So let's consider the polynomial equation p of x is equals to 2x plus 1. Let p of x be equal to 0. That is, we are equating the given polynomial to 0. That is, x plus 1 is equals to 0. Then solving this equation, we get 2x is equals to minus 1. Therefore, x is equals to minus 1 by 2. Then, substituting the value of x in the given polynomial equation, we have p of minus 1 by 2 is equals to 2 into minus 1 by 2 plus 1, which is equals to minus 1 plus 1, which is equals to 0. Therefore, x is equals to minus 1 by 2 is the 0 of the polynomial p of x is equals to 2x plus 1. Let's take another example, x square minus 25. let's consider p of x to be equal to x square minus 25. Then when p of x is equals to 0, x square minus 25 becomes 0. Then x square is equals to 25. X will be equal to root 25. Therefore, x will be equal to plus or minus 5. Substituting this value of x in the given polynomial equation, we have p of 5 is equals to 5 square minus 25. That is 25 minus 25 is equal to 0. Also, when x is equals to minus 5, p of minus 5 is equals to minus 5 the whole square minus 25, that is equals to 25 minus 25, which is equal to 0. Therefore, x is equal to minus 5 and 5 are the zeros of the polynomial. P of x is equals to x square minus 25. So, to find the zero of the given polynomial, first consider the polynomial equation, equate it to 0 and then solve the equation. Next, if y is equals to minus 4 is the zero of the polynomial, p of y is equals to y square plus ky plus 60. Find the value of k. Here, 0 of the polynomial is given and we need to find the value of k. Solution: since y is equals to minus 4 is the zero of the polynomial p of y, p of minus 4 is equals to 0. That is, minus 4 the whole square plus k into minus 4 plus 60 is equals to 0. That is, we have substituted minus 4 for y in p of y. That becomes 16 minus 4k plus 60. That since minus 4 square is 16, k into minus 4 is minus 4k. Now 16 plus 60 makes it 76. So it becomes minus 4k plus 76 is equals to 0. Now shifting 76 to the other side of the equality, we get minus 4k is equals to minus 76. Minus and minus on both sides of the equality gets cancelled. So we get 4k is equals to 76. So k is equals to 76 divided by 4. So 4 19s is 76. Hence k will be equal to 19. Therefore, the value of k is equals to 19. Let's take another example. If x is equals to 2 and x is equals to 0 are the roots of the polynomial p of x which is equal to 2x cube minus 5x square plus ax plus b, find the value of a and b. Here, two roots or zeros are given for the polynomial p of x and we need to find the value of a and b. Since x is equals to 2 and x is equals to 0 are the roots of the polynomial p of x, p of 2 will be equal to 0 and p of 0 will be equal to 0. Now substituting 2 in p of x for x, we get 2 into 2 cube minus 5 into 2 square plus a into 2 plus b is equals to 0. Now 2 cube is 8 and 2 square is 4. That becomes 2 into 8 minus 5 into 4 plus 2a plus b is equals to 0. That is 16 minus 20 plus 2a plus b is equals to 0. Now 16 minus 20 is minus 4 plus 2b plus b is equals to 0. We take it as equation 1. Since here we need to apply the value of b so that we can get a. Now moving on to the next. P of 0 is equals to 0. That is 2 into 0 cube minus 5 into 0 square plus a into 0 plus b is equals to 0. 2 into 0 minus 5 into 0 plus 0 plus b is equals to 0. That is 2 into 0 cube minus 5 into 0 square plus a into 0 plus b is equals to 0. 0 cube is 0, 0 square is also a 0. Therefore, 2 into 0 minus 5 into 0 plus a into 0 is again a 0 plus b is equals to 0. So this is 0 minus 0 plus 0 plus b will be equal to 0. Therefore, b becomes equals to 0. Take it as equation 2. Now substituting b is equals to 0 in equation 1, that is substituting 2 in 1, we get minus 4 plus 2a plus 0 is equals to 0. That is minus 4 plus 2a is equals to 0. Shifting minus 4 to the other side of the equality, we get 2a is equals to 4. Therefore, a is equals to 4 by 2. So, simplifying, 2 1s are, 2 2s are. We get a is equals to 2. Therefore, the value of a is equals to 2 and of b is 0. We now know to find the unknown value of a polynomial if its roots or zeros are given. We now know 0 polynomial and 0 of a polynomial. To find 0 of a polynomial, to check whether the given zeros are the zeros of the given polynomial. To find unknown value of the polynomial when its zeros are given. Thank you.